Let's start the stream. Maybe put the camera up here. Yeah. Okay. Let's see. Where do we start? We start with today's post. A while back. Well, let's go back to the 18th. 10 or so, 2 weeks ago, week and a half. And we need some sort of serial number system for sound playback, so that when Lisp in sound.c, when a play async call is issued, to cancel, you need to be given some sort of a token, and that token is a playback ID, which first 6 bits are an index into an array of mini audio resources. So the sound.c module can locate those to cancel, and a serial number, which is the serial number of playback, so that at some other time, if a particular, well, let's see, let's bring this up. If a particular what? Well, I'm looking for it. Particular item in G sound list, which that's a list of mini audio resources for sounds currently being played. But anyways, we want to avoid this scenario. Where is this scenario? So you issue play asynchronous call as a client, say in Lisp. Return an index. This is the original implementation into G sound list. Sound begins playing, and cancellation, freeing of mini audio resources, occurs by client calling cancel asynchronous and the index that it was given, or the playback completes, and there's a callback inside the C code which figures out when the playback is finished. In both cases, the mini audio resources are free. But the following could occur: steps 1 through 3, after playback, another piece of client code or whatever, request playback of another sound or the same sound, but let's say it's another sound, and receives the same index as in step 2 above. And so if another part of the client code believes that the original playback above is still in progress, and requests cancellation, it's going to cancel somebody else's playback. So we want to avoid that, and that's what the serial number does. Because on every play asynchronous call, the serial number is incremented. Playback IDs are stored in a 32-bit unsigned integer, like so. Error codes are also returned in this 32-bit integer, and the lowest 6 bits will be set to 1, which means that your little bit, you have a bit of a limitation. You have less than 6 bits for your number of concurrent sounds that can be playing, which is fine. 63 or whatever. Okay, and I mentioned in a previous stream, and I don't recall which stream, that I would much prefer to use Bitfields because these functions, I have 7 functions to mash things together. Where are they? Are they here? Right here. Right there, they're all small, tiny things. And they're not static. Originally they were Originally they were macros, but I decided that I would like to export these to client code. So they can't be static, they can't be inline. Okay, so and then you have to do ugly things like this for error codes, or it just doesn't make sense. It just doesn't. It makes it harder to read. And what we'd really like to do is say, let me go to, I don't know. We'd really like to, well, let's do this. Control XD, example. We would really like to say return value dot XD to XD, excuse me for a moment. We'd really like to have struct like, well, we'd really like this. Let's just pretend we do. And we would, so this, no, this represents the lower 6 bits, the 2 different kinds of objects that can be stored there, values. And this is the upper 26. Serial number and error code. So if this is all 1s right here, if this is all 1s right there, then we would use this field. And if it's not all 1s, then this is an index, and that's our serial number. And so we would like to, let's just say we have an error condition. -1, that's all 1s. Notice that it's an int 8. And then let's find an error code here. Not that. Let's go to sound.c. Say it's just say error in sound playbacks, no free slots, and then just like so. That's what we would like. So let's go through this. We already have the motivation I just explained. So my first attempt at using Bitfields, I did this, like so. And let's run the compiled version. We need these structs to be 4 bytes, so they can fit into a single 32-bit unsigned integer. And we need that because we're returning those back into the Lisp world, and there's just no good way to return multiple values that I know of, to return multiple values to a Lisp function through CFFI. Excuse me. So let's run this. And we get 4 bytes and 5 bytes. So which one gave us 5 bytes? Well, that would be the second one. This one right here. And that's that structure here, where we have 2 unions, and each member in one is 6 bits, and then each member in the second is 26. The compiler just isn't smart enough to pack all that together. Okay, so one alternative is to just give these fields a big ugly name. And so this bit field here, 6 bits, is just named index or error flag for an ID. And this is named serial number or error code. Both of these are packed, by the way. If you don't pack this, this is 8 bytes for some reason, probably alignment. And so if we check the first printf here, this size is, boom, 4 bytes. That's what we want. Okay. And so I'm okay with this type def, number 2, the second one, the one with the multiple name, the naming convention indicating multiple uses rather than the using a union. And so I'm going to use that. However, C standard makes no guarantees about the ordering of bit fields. In my initial Shif mask or implementation, this is completely under my control. So go here, take open link tab. Let's get rid of my other tabs here. This looks like a very interesting site. Algorithm. I'm totally just mentioning this. Algorithmica. Algorithms for modern hardware. And they talk a lot about modern hardware. And they have a great quote up here. I'm sidetracking. Floating point numbers. The users of floating point arithmetic deserve one of these IQ bell curve memes, which is the midwit meme. So there's like a slow person here and average intelligence here, and then super smart person over here. And because and they say this is how the relationship between floating point and programmers typically proceeds. Beginner programmers use it everywhere as if it was magic, unlimited precision storage type. Then they discover that 0.01 plus 0.1 plus 0.2 is not equal to 0.3 or some other quirk like that. Freak out. Start thinking that some random error term is added to every computation, and for many years avoid any real data types. When they mean real, they mean floating point completely. Then they finally man up, read the spec of how they work, and start using them appropriately. Well, the spec, unofficial spec, is, where is the spec? It's what every computer scientist should know about floating point, and it's this big, long, there has to be something that's more usable. So I have it manned up, and maybe they're just, maybe this resource. I'll put a link to this in the description. It's called Algorithmica. It's an open source web book devoted to design algorithms for modern hardware. So I'll leave that tab up. Leave that up. Leave that up. Leave. Well, I'm sorry. We'll close that. We'll close that. Okay. What was I gonna do? I forgot what I was gonna do. Email me if you remember what I was going to do. I was closing stuff. Too many things to keep in my head while I do these. I'm looking over at the screen here. Where? Over here to my left. I'm moving the mouse around. I'm working with Emacs. I'm trying to make it readable, and I'm talking. And this is embarrassing. I have forgotten why I went to the web browser. Maybe I went to the web browser to finish reading this. That's what I'm going to do. I'm editing this out. For sure. The C standard makes no guarantees about the ordering of Bitfields in my initial shift mask or implementation. This was totally under my control. Yes, and here it is, under my control. I knew exactly where every bit went. Now I don't. I just know that my object is 4 bytes long. So, since I knew where everything was, well, there was one other hidden assumption of mine, and I'll get to that in a second. Since I knew where everything was, in list code, I could assume that an error flag test could be written. You get a playback ID from calling play file async, and if we have all 1 bits, then we have an error condition. All 1 bits in the lower 6. Okay, I'm not going to cover the other assumption. Okay, so we're going to have to do some testing to see where the bits are going when we use Bitfields. That's our first thing. So number 1, fidget around and test bit ordering in this type def right here. Once we, and so we'll need to remember that the Lisp code, if we have a different bit ordering, the Lisp code will have to keep that in mind. I'm going to cross my fingers and hope that it's just ordered in the way it's listed, defined in the structure. So first field is the first 6 bits and 26. Okay, so number 2, add definition number 2 to sound.c and replace all those calls. Get rid of those functions and replace the calls to them with ordinary field references, period. Let's fix that. Let's get rid of some windows here. Clickbait we'll get rid of. Get rid of this. Get rid of the desktop for now. Let's fix that period. Okay, so what do I mean by fidget around? Well, usually it doesn't mean anything, but I have something specific in mind, and that's determine the bit ordering. But we might need to do some other fidgeting. So there will be some fidgeting will occur. We're going to fidget with this program. And we're gonna so void print bits low to high. So we're going to print in little endian. And we are going to cast these playback IDs to, or this, we have already decided that this is gone. So let's get rid of that. And let's hope that we can cast that structure to a uint32t, and we'll just, I don't know, we'll call it n. Okay. And we should be able to just grab that from another function here in some other file, which I wrote the other day. What do we call this thing? PBID. Let's just do, well, we're still going to print 6 bits, a space, and then 26. Let's just print whatever garbage is in there, and then we'll make some assignments. Well, let's make an assignment right here where we declare. So dot ID, we'll say equals -1. Equals 666. Not semicolon, it should be a comma. And we'll leave that What is the binary for 666? Sorry, Emacs, this calculator is much better than yours. I know there's a casual calc, but I don't have, my Emacs version is not sufficiently high, that we're doing entering hex. Okay, we enter in decimal, and it prints in hex. That's fine. So result format will be binary, binary. Okay. 1010. Okay, so what can I do? Like 0B 102 4. Let's do this. 4, 6, 8, 10, 12, 14, 16, 18, 20. That's going to be reversed since we're printing in a little endian, so it'll print as 01, 01, 01 instead of 10, 10, 10. And what is that in decimal? We'll say general 699050. Okay, 699050. Compile. And error operand where arithmetic all right, I need to read the full message. Operand of type playback IDT where arithmetic or pointer type is required. Well, that's no good. I can't print the damn thing. I'm going to have to resort to pointers. Okay. I hope I don't have to do anything like this when I'm really using these. Or worse. We'll cross that bridge when we get to it. Okay, go back and let's see what happens. What is it going to print? 0, 1, 0. Well, no, we have to fix something. Our prompt is on the same line, and it's confusing me. It's the very last digit. Didn't we want 26 of those? Pairs? Okay, we'll figure that out in a second. So what do we got here? Well, we have 26. Okay. Well, maybe the calculator is throwing me off. No, I don't want that. 0, 1, 0. Copy. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I guess I just didn't. Precision, 50 digits. E25. No, we want 26 digits of precision. So result format, precision. Well, we can't. We get 15 and then it jumps to 50. Okay. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Maybe maybe if I wrote it in the right radix, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. What is that in decimal? It's 447,39242. Well, let's see if I copy this. Sometimes when I copy from Windows and paste into Emacs, it crashes. Emacs just wants to live in its own little world. It kind of wants to interoperate, but not really. Oops. I'm not going to tell you why that happened, because Emacs wants to live in its own little world. There it is. Compile. eShell 0101 there. Okay, so left to right, little endians 1111 01010101. Just as I suspected, which is good. Okay, so now we can get to the business. This is nice because now we can. We can get rid of those 7 functions. And we're going to do that at this moment now. Okay, so what else? So that was 1. Add the definition number 2 to sound.c. And I'm just going to replace them. I'm not going to take these live streams. 1.5 hours to 2 hours might equal 15 minutes of real, actual coding. Some people can rip through stuff while they do these live streams, their live streams. I don't. There's too much talking for me and not enough focusing on what I'm doing. So now we are going to just yank these fearlessly, and we'll never see them again. Okay, and these are gone. let's use our fabulous, no. Let's use our fabulous thing that I can't remember the keybind for. Because I spent time reconfiguring my Emacs, so the key binding damned well better be available. MC mark next like this. Control. When did it get to be that? Sidetrack time because Emacs, that's why. Let me look at my .emacs.init file. Freshly configured. How long have I been going? Let's see. I might finish my Galactic Battlegrounds game tonight. And live, I've been going for 36 minutes. Okay. Okay, yeah, it is control. Okay, so I'm okay. So it's 1. Okay. There. Also, I could kill the ends of those lines. Yes, and it doesn't work. Come on. I need to get my fingers used to these because if I have 200 of these things and I want to edit them all at once. So this is practice. So I think I know this one. Nope, I don't. There. So I want to go to the beginning and then I want to hit Shift E and it cancels. Okay, I give up. Well, now it's back. Later. Okay. How can we, I would like, okay, I would like to say this. I would like to say here that this is an error T. let's do a little bit more fidgeting. I would like to say so we're back. I'm back in Bitfield test, like my little test program. I would like to, instead of call this, I'd like to call it. Okay, and we'll compile. And let's go to eShell and see what we get. Still 4. It looks exactly the same. So you can use a more descriptive type for that member. It would be nice if I could tell the compiler, use 4 bytes for error T, but I can't. But it turns out that's what I got anyways. So let's pull that structure from here. Put it right there. Okay, and let's go through and look at some of our code that we have. That passes. This static playback IDT. So somewhere we have some code, make playback ID. I don't think we need this. So result dot naturally my LSP client egglot playback IDT should be giving me the members for that, or at least should tell me. Well, this is equals, and we're going to set this to a default. I wonder if you hit like dot and then ID and you hit, if it would list the fields. It's probably not that smart. So ID equals E. We'll say no free slots as a default value. Otherwise, not give me anything. Because why? Because it couldn't compile that, or because it's confused by the Bitfields, or it shouldn't be because it's packed. Who knows? But we have this mechanism to the rescue. Should be a serial number, global variable somewhere. I guess there's not. Okay, G serial. Okay. Plus plus, and it wraps around. We're okay with it wrapping around. Now these error codes should really be, I think the error codes should be like, it should be this structure here. So we should say something instead. And we'll there's a little bit more. Oh yeah. We should be able to say something like const. Down here, we should be able to say something like const. And then E right, for all 4 error codes. In fact, that's what we're going to do. And we're going to have to redefine this enum. So we'll call it, we'll call these, you know, E code or error code, error, something. That way when we return a value or assign an error code, we can just, we don't have to set, this makes it even easier. To work with these. We don't have to say, you know, dot ID, IDX or error flag equals -1. We just say, if we're going to return the error code, we return one of these things. Return that. And so that's what we'll do for the others. Super easy. And we'll use the magic of macros because this is also a watch Emacs in action. Oops. Livestream. How would we do this as a macro? Control X, left bracket, define keyboard macro, copy that, and then we say const. Okay, and then we go to the end, and then we say equals. If we have errors while we're, you know, we have to back up in our macro, who cares? Dot ID, IDX equals -1, comma, dot ID equals control Y, and then control this, control X, control that, presto, presto. Now if we had 200 of those, we need to do this. If we had 200 of those, that would be a quite a help. Okay, now we need to rename these. We'll just call it ERR code. And yeah, we can do this. That's one minus of the CUA mode column functionality is it doesn't handle undo very well. So you better know what you're going to type when you're in that mode. Okay, so we've got that. Now we can just say presto. And here, we can just return that. Okay. And now, let's see, results. Did it find it? Yes, it compiled for some strange reason now. So LSP can return something. And it's ID exit error flag equals I. Go to exit, unlock the mutex, which we locked up here. Okay, very good. And so on. This is probably best done by myself in isolation. But it's really just a matter of going through all the code here below. I'm a little bit less than halfway through it, 40%. And making sure that everything uses these playback ID T's, this data struct that I declared up above. But I think it's going to work out quite well. And we have found that just showing the raw bit structure, raw bits, they're laid out exactly like a 32-bit integer and little endian. Well, that's another story. I won't get into that right now. But so when we go into our Lisp code and use this stuff, all of this these will be numbers. So we won't. They will all be numbers. Which might not be the best design, because CFFI does handle structs. Does it handle Bitfields? Let's see what the internet has to say. CFFI is an add-on, as a library, Common Lisp library for C and Common Lisp interoperability. It works very, very well. CFFI Bitfields. Let's see what it has to say. Here's the user manual. Let's okay. How about struct? Foreign. Is this still CFFI? It's quite old. It's incredibly useful. Def union, def struct, def bitfield. Oh, well, you know, I think that I'm going to look into this because I can work in the that might mean that I can work on the Lisp side, very similar to the C side. If we have bitfields, and of course we have structs. I wonder, let's just read through this really quick. Macro, def bitfield, name and options. Okay, name and an integer representing a bit mask. Let's see how this might work. Is used to define foreign types that map lists of symbols to integer values. I think this is quite different from a C bit field. But we might be able to use it for our purposes because Def Bitfield macro is used to define foreign types that map lists of symbols to integer values. If value is omitted, it will be computed in some way. Let's see. So here we have def Bitfield open flags. Yeah, no, we can use this. We can use this. How do you use, well, how, okay, there's the def, but I think, well, no. I think this is really, okay, this is a good example. Okay, so here's the open C call. And you would really like to use the usual flags here. You'd like to have similar flags, similar to what you'd use in C, and so there they are. But that does not mean that this could not be. Yeah, I think I can use this. Okay, I'll keep that in mind. All right, time's up. Pretty much. How many? Well, let's double check. How long have I been on? Somebody said new subscriber. Some guy. Okay. How long have I been going? Nobody is watching. I don't care. 2 upvotes. That's good. Okay. And 1 viewer. Well, I do have 1 viewer. Okay, so how long have I been doing this? I've been doing this for 56 minutes, and that's my limit. Next stream, I'll have added these playback IDs everywhere they need to be, and I'm going to go through the code and make sure that we don't have any deadlocks or race conditions in our. We have at least 2 threads. Yeah. We have 2 threads. It's conceivable there will be more. Excuse me. I'm not going to go through and formally verify this because I don't know how. But I'm going to get, it's so simple, I'm going to use informal reasoning to convince myself that we don't have any multi-thread type errors. And then we can move away from this file. It's only 370 lines or whatever. Finish this up and get back to Common Lisp and work on some other parts of the game. And I think also my next post, I'm going to sort of state my intents of these streams. I'll do it right now, but I'll write it down. Is I'm working on code that can be used during the Lisp game jam in the fall, or maybe later. And I can't, the rules state that you can't really work on the game except for the 10 days between the start and end. But you can work on, you can work on things like this, things that aren't directly related. So this is what I'm doing, and hopefully I'll have enough in place so that I can rip through the game when I join the game, next game jam that I join. So, okay, thank you. I might stream again tonight, and let's I might finish let's go to YouTube. I might finish. Now you know what kind of stuff. What is this? Look at this AI generated stuff. Alien 1979 Nostromo. Mother. The computer was known as Mother. Mainframe. Ambience. 6 hours. Extended sound. I'm not going to play it. But one of my previous streams, yes, I was playing Galactic Battlegrounds 1 versus 1, and I stole all the enemies' holocrons and locked myself into a fortress, barricaded myself into a fortress, and I was hoping to slowly wear him down by attrition because he kept launching attack after attack after attack, but my fortress is practically impenetrable, easy to repair, so maybe I'll wrap that up tonight. I could just barrel through there with a bunch of air cruisers and destroy everything in about 10 minutes. But I don't want to do that. I want to have more fun. All right. Until then, thank you.